Hello everyone, welcome to today's webinar. This is the final episode of our 12-part webinar series on countermeasure strategies for pedestrian safety. Today's presentation is going to focus on pedestrian safety at transit locations. And we're going to talk about all different types of transit today. The presentation is going to be delivered by Dan Neighbors with VHB, and we're really happy to have him here today to talk us through some safety issues associated with transit and pedestrian safety. My name is Dan Jaleen. I will be facilitating the webinar today. Attendees, if you can hear me, I'd like to ask you to please click the hand icon that's located in the upper right-hand corner of your screen. That'll just let me know that the webinar system is working properly and that you can hear me. So I'll just take a look here and see if I see hands going up, and I do. Great. Thank you very much. We're excited to have you all joining us today for this session. Before we get I just wanted to go through a few administrative details about the webinar software. If for whatever reason your computer freezes, you should be able to reload the session and log back into the program. We will actually have already posted the slides from today's webinar. I'll share that link with you in just a moment so you can follow along, but you will be able to look back at anything you missed because the slides are up and available to you. We will be also recording the webinar today and plan to have that posted up on our website within 1 to 2 weeks after the presentation today. Please note that attendees won't be able to speak during the webinar, although you will have the ability to submit questions and comments to us using your chat function. You can ask those questions at any time. We plan to hold some time at the end of the webinar today for a discussion period, although the bulk of the presentation today will be focused mainly on getting through the material. We do have a lot to share with you today. So please ask those questions, and we'll do it best we can to answer as many of them as possible. And we'll also provide you with our email account unless you'd like to follow up, in case you'd like to follow up with us about getting those questions answered. Later today, you're all going to be receiving a follow-up email from the UNC Highway Safety Research Center. The email is going to include a link that will allow you to generate a certificate of attendance for the webinar today. So if you're attending the webinar with multiple people at your site, please just make sure to forward that message to each of them so that they can all produce their own certificates of attendance. The email is also going to contain a link to the website where we've already posted the slides from today's webinar. That same page will have the video recording of the webinar within 1 to 2 weeks of today's presentation. We've submitted the webinar to the American Planning Association to be considered for 1.5 CM credits. So I'd encourage you to please check their event calendar online to find out when that webinar has been approved and when you can claim those credits. You can learn more about PBIC webinars or even watch some of our past episodes by visiting petbikeinfo.org/webinars. Just one more thing I want to do before we start the presentation today is take a quick poll of the audience. We're interested in finding out about how many people are out there attending the webinar today. Specifically, how many are attending from each site. So if you can let us know, how many people are there with you. Is it just you? Do you have 2 or 3 people with you? 4 or 5, maybe more. We're just interested in finding out a little bit more about how many people are out there. So I'll probably leave this open for another 10 seconds or so, so we don't have to spend too much time on it. So if you can go ahead and cast your vote, we'll go ahead and move on with the feature presentation. Okay, just a few more seconds on the poll and I'll close it up. All right. Well, thanks very much, everybody, for participating in that poll. We really do appreciate it. Without any more delay, I'm going to turn it over here to Dan Neighbors to continue the presentation. So Dan, whenever you see that come across your screen, you can go ahead and accept screen control and show your screen, and we should be good to go. Okay. Yeah, I see your screen, Dan. You're all set.
Great. Thank you, Dan. Okay. Like Dan said, we have a lot to go over here. So let's just go right into it. We're talking about transit stop improvements and some of the design considerations with regard to transit and pedestrian safety. So what we'll talk about are the different types of transit, because different types of transit are being explored more and more as ways to increase system capacity in the transportation network. We'll talk about some common transit considerations. It's not going to be comprehensive due to the amount of time we have and the amount of material for all the different forms of transit you can see right there. And it does assume as well that you've taken the previous course that was designed through FHWA several years ago. I will talk about some of the resources, and just keep in mind the intent when this is usually delivered in person is that the agency that is requesting this transit module will actually select any number of those 5 different transit options that are available there. But I'm going to touch on each of those and some of the key considerations through the course of this presentation. So most of the material focuses on local bus service, since it's the most common form of public transportation. With the local bus service, the average operating speed is lower due to its operating with general traffic and stopping more frequently. And of course, there can be differences in services that are oriented more towards commuters like BRT and things like that. For the most part, it's the most common, and that it uses the existing right-of-way. So that's what we're talking about when we discuss local bus service. We will talk about other transit types as well. And again, the whole intention of transit is to support reduction of vehicle trips to increase the system capacity. Transit as a whole encourages sustainable development and supports greater accessibility, housing options, employment, economic development to a broad cross-section of people. Transit also reinforces walkable streets, neighborhoods, and in towns and cities, and these are just some of the higher level benefits provided by transit. So just an overview of some of those other forms that I just showed you. We'll start with streetcars. Obviously, streetcars operate along rails that are within the street. Often they operate with mixed traffic, so in that sense, they have a lower travel speed and are more like that local bus service that I first started talking about. A streetcar will serve smaller areas, typically that are connected to local major destinations, and they'll also make frequent stops very similar to local bus as well. But streetcars have this view as contributing to higher levels of economic development due to their sense of permanence, unlike local bus service. And that's associated with the existence of the rail infrastructure. That means that they can't be easily changed, and that's one of those things that really generates that kind of economic interest in streetcars. BRT, or bus rapid transit, is viewed as a lower cost alternative to rail transit due to the lack of in-street infrastructure, typically rails, that is needed. But BRT also has a lot of the same operating characteristics associated with light rail, and we'll talk about that in more detail. This is accomplished through some of the things you see on this slide, such as the low floor vehicles with elevated station platforms that allow for level boarding of passengers, which reduces the time that BRT vehicles spend at each stop. BRT also sometimes operates within a separate running way to improve travel speeds of the vehicle. And BRT includes fixed stations and off-board fare collection that is similar to sometimes streetcars or light rail as well. And then BRT also has increased station spacing, which means that it operates faster. And then there's sometimes transit signal priority, which is applied to BRT, which is just a signal system that extends or advances the green signal for transit as the bus approaches the intersection. And again, the goal of that is to improve the travel speed of the transit system. Now, all these things together are what's sometimes referred to as the gold standard, like you want to have all these things when you're designing a BRT system. But it seems to be an increasing challenge to have all these components. And so, due to lack of right-of-way or funding or availability of other features, so some BRT systems have some of these characteristics now, but not all of them. And we'll talk about that a little bit more detail. But your true BRT system will have all of those. Light rail operates on a fixed rail, of course, similar to streetcar, except the rails are typically separated from traffic. This allows for faster travel speeds compared to the streetcar or local bus, maybe sometimes 10 to 20 miles an hour faster. The station locations are fixed, and off-board fare collection as a means to improve travel speeds are also provided, similar to what I talked about with BRT. Commuter rail or heavy rail operates an exclusive right-of-way, which allows for higher travel speeds. It's primarily designed for connecting commuters, and the stations are spaced farther apart, which results in large rider populations concentrated around stations, which also requires special facilities to accommodate parking and drop-offs from buses and other vehicles as well. Commuter rail is often focused in morning and evening travel, resulting in lower frequency of service as well. So that's a brief overview of some of the forms of transit, so you kind of get a general comparison in terms of what the differences are. Now the goal of all transit is basically to carry passengers in a safe and efficient manner. And it's not only the objective of retaining passengers, but also to encourage new riders. However, there's challenges to this, and these are listed on this page. I'm not going to go over each of these, but they're just shown here to illustrate the complexity of the issues that transit agencies have to deal with. So the main agencies, though, that typically will deal with transit are your transit and your roadway agency, either DOT or Public Works, and that's the real kind of team approach is centered around those two agencies. There's also enforcement, private developers, nonprofit organizations, and other agencies that are participating, but these two agencies really have the vested interest in the core areas. For the transit agency being ridership and the placement of transit facilities, and for the road agency, the roadways, and of course ensuring that there's no crashes on the roadways as well. So you can see in this example, it just kind of shows you where that crossover between the responsibilities of the DOT and transit are, is that the DOT has responsibility for the roadways and the transit agency for the stops, and there's that shared responsibility often in locating those facilities. So, how does a transit agency and roadway agency consider or focus on addressing safety for transit riders? Well, really looking at these focus areas is a way to prioritize concerns. So the first, higher use locations or high ridership locations, entails looking at part of the system that is used the most. The second consideration, focusing improvements where existing infrastructure is lacking or complete, is usually conducted through some sort of inventory where you're looking at the transit facilities that are being provided. And the final consideration for providing focus and identifying safety needs would be through the review of high incidence locations. Reviewing crash data around stops that involve pedestrians or bicyclists may highlight issues associated with the location or design of a bus stop and the surrounding area. And again, the real critical thing is the ability to look at all these components together, as you can kind of see on this slide. Identifying the stops with the highest ridership is one of those things you would want to look at. You'd also incorporate your inventory over the review of elements and then plotting crashes. And it might be hard to see on this, but those are all plotted together. So what you end up with is concerns at different levels. Concerns where you have something that is unique to a particular location because of some sort of unique conditions. And so here you have a kind of cross-section of a route with high transit ridership indicated by the thickness of the blue line. And then you also have, from the transit inventory, you see that there's improvements needed at the stops and that there's also crashes occurring there. And so that's something that you might want to address through a site-specific review and concern. You also can have priority corridors, which are your most heavily used corridors, again indicated by the thickness of that blue line. And here, enhanced crossings along the corridor are key because you have such high ridership. You can also have a secondary corridor that you see, and that might be lower priority. There's less frequent service or there's less frequent stops, and that may include low-cost crossing enhancements such as signing and pavement markings. And then you can have system-wide considerations where you see something that is kind of common to all the features. And again, these are things that you would want to apply low-cost dispersed measures that is kind of more in line with the systemic safety philosophy of applying improvements in a systemic manner. So I won't go into a lot of detail on these sources of guidance, but these are the primary sources here. Obviously, the MUTCD has, and you see the parts listed there that pertain to transit. ADA, of course, is critical, and I'll talk about some of those things as we go through the presentation. But one important point with regard to ADA is that the more accessible you make a system, then the less you rely on other services like paratransit. So this can have overall cost savings for the agency. So ADA again is more just that than serving people with particular needs. It serves the whole public. Other agencies, or there's other guides too that you could see here. This toolkit for the assessment of bus stop accessibility and safety. That's something that could be used to look at accessibility as well. That was produced by the Easter Seals Project Action. And other transit agency documents too, such as design guides, are also important when you're looking at transit. And a lot of the local agency transit guides will have their own location and design standards that need to be consulted. Finally, other documents. You see one of the things that's shown on this slide is the Pedestrian Safety Guide for Transit Agencies produced by FHWA. That provides some good information, as well as other things such as PedSafe, which we've talked about through some of these webinars too in the past, also produced by FHWA. So that's kind of the general overview. We're going to talk about specific topics for each of the types of transit. This is kind of an overview we'll go through. We'll talk about some of the major considerations and areas of caution with regard to bus stops. This provides an overview. Again, these are things that were talked about in the 101 course, as we label it, the first round of pedestrian safety and design courses that were developed through this program. And the thing I'll point out is that there's just three particular types of bus stops. You have the bus bulb and nub, which is a bus stop in conjunction with a bulb out. You have a bus bay, which is kind of where you have the bus in its own bay, and there's obviously considerations with each of those that are listed there. And the queue jumper, which we didn't talk about a lot in the previous course, but it's something that kind of combines with the transit signal priority that I briefly mentioned, and that's just a way that enables the bus to bypass queuing traffic in an intersection and provides that prioritized bus service. The other thing that we'll talk about today, and these again are things that we've talked about in the previous course, are placement of stop. Far side refers to the bus on the far side of an intersection. Near side is on the near side of an intersection, and mid-block, of course, is between intersections. And there's advantages and disadvantages to each that are listed. I won't go over those in a lot of detail, but I will start by mentioning that when you are talking about mid-block bus stops, that's one of those areas that sometimes you might not see any indication that there's crashes in an area or pedestrian crashes other than the existence of a stop. So it's important to consider that mid-block stops may be pedestrian generated, and how they integrate with the surrounding land use is a critical consideration as well. You can see in both these slides, these are just these pictures, so it's just these high demand mid-block crossings that are really because of the presence of that bus stop. So locating bus stops, it's critical to locate bus stops at an intersection when possible. However, when you place it the bus stops on one side of the intersection, it might focus the activity on one side of the intersection, so people coming from other directions, in this example you see it on kind of the left side of the intersection or the west side, it might favor people that are on that side. So there's a reason that you might want to do that, but it might be helpful too to look at placing the bus stops diagonal, either on the near side or far side, based off of prevailing conditions, because that might distribute the traffic, pedestrian traffic, and align better with some of the land uses more in a more positive manner. Other considerations when you're placing bus stops close to intersections are transfers. You see here, having a bus stop, these two bus stops in this manner that's depicted requires a pedestrian to cross the street. And it could be a better, possibly, consideration is to place that bus stop on the same quadrant of the street. Of course, you'd have to develop adequate facilities for the demand that might be there. But again, these are just higher level considerations that when you're looking at transit stop placement, looking at the activity around intersections and how people are not only crossing, but how people are using the sidewalks and the effect of waiting passengers on the sidewalks. Driveways are another consideration that's often discussed when siting bus stops. Typically you don't want to place bus stops over driveways, which makes sense. That should be avoided. However, it might be unavoidable in some instances. But in this location, as you can see here, you want to consider possible movements out of the driveways and sight distance considerations. That could be a factor. So if you have a left-turning vehicle coming out of the driveway you see here, they would be shielded by the placement of that bus stop, which could result in a collision with a vehicle that's going from the right side of the screen to the left side of the screen. So you wouldn't want to do that. Some instances it may be unavoidable, and so there's considerations that it might be acceptable. Of course, this requires coordination with the adjacent property owner if there is a secondary access. And of course, these are just things to consider. There's a lot of things that are factors in these considerations, such as how long a bus would be dwelling there, is it an active stop or not, and things of that nature. But just consider the effect of access management on placement of bus stops. And that does affect pedestrian safety as well. So with some of the specifics with bus stop design are here. Of course, I'll talk about some ADA, I'll talk about amenities, and amenities are really based off of two primary factors, the usage of the bus stop and the space that's available. And we'll talk about that a little bit more. And then, of course, travel patterns and flows around the bus stop are critical as well, not only from the pedestrian standpoint, but from the pedestrian vehicle interaction standpoint as well. So here's kind of your basic ADA standards for bus stop design. You can see the basic requirement is to have a boarding and alighting area that is a 60 inch by 96 inch level area. That has to be connected to an accessible route, which by the PROAG is 48 inches minimum. And you can see here, this is just depicting how it's connected to a bus shelter, where under the shelter you have to have space for somebody that's in a wheelchair, 30 inches by 48 inches. So that's kind of your basic requirements. And you'll see in this next series of slides, we'll show how you kind of build off of that basic requirement of that 5-foot by 8-foot accessible pad. That's that 60 inch by 96 inch pad. The other thing to note too is that a bus stop sign should designate where somebody is to access the wheelchair lift on that accessible pad. And you can see the picture on the lower right there shows that accessible pad and the sidewalk as kind of just your basic level of design. There is a looks like a newspaper box placed on that, which would be discouraged because you want to keep that free from obstructions. So Ideally, you'll be able to provide an expanded landing pad so that people that are boarding or lighting the bus can use the front and back doors. And so that's about 40 inches, or excuse me, that's 40 feet for a standard bus, and for an articulated bus, it's longer, about 62 feet. Ideally, that the 8-foot deep pad should be maintained the length of that bus. You can also have amenities, such as a bench. The bench could be freestanding or part of a shelter. Those are typically recommended in areas where you have headways greater than 15 minutes, but it shouldn't conflict with that landing pad, that ADA pad. So a shelter is another enhancement. A shelter is sometimes, some agencies recommended it for stops of 50 more boardings. It should contain a clear area, which I talked about before. And it could be located on the landing pad, but you have to maintain that accessible pathway, remember. So the shelter should not obstruct the sidewalk as well. The shelter shouldn't be placed closer than 2 feet from the curb as well to avoid being struck by the mirrors on the bus. Trash receptacles are other things that can be provided. Again, they shouldn't conflict with any of the things that I've described to this point. Potential bike rack locations, those could be placed in conjunction, particularly with some of your higher use stops. There's a potential location there. Potential location too, away from that landing pad. Just a few locations that we've seen applied successfully, but it should be discouraged from right adjacent to that landing pad, because sometimes the way people, hook up their bikes or their bicycles will, kind of block that pad, and you want nothing to block that 5x8 landing pad. So you don't want to do that. Of course, all these things that we're talking about, lighting is required, and all these features that I'm describing should be illuminated. So these features can be incorporated into different bus stop types. You see here the blue lines, and then the blue triangle is I know my shape's better than that. Blue rectangle is indicating a parked vehicle, so you can see there's a bus bulb nub, also a bus bay it could be used, or a queue jumper, or on the near side of an intersection. So this just shows you some examples. Here's a suburban example of putting it all together, where you have the landing, you have the accessible route behind the landing, and you see a crosswalk with ramp located near the stop. Although this is an older ramp that doesn't have truncated domes and things like that. But the basic elements are what I wanted to point out. This is an urban example where you can see you have your level landing, and this is actually in conjunction with the transit shelter. It is accessible, has an accessible route, and it's located close to a crosswalk, and it's on a stop. Now, some of the areas of caution is that sometimes you might have areas where you have, or it's necessary to have bus queuing, and there's ways that you can handle that. You can see in this specific example here, they have these staggered bus bays, which allows for 3 buses to queue in at a time. Now, locations where you have to have multiple buses, it's ideal to have these on lower volume streets, and in this case, you can't see, but where the picture is taken from, there's a crossing, and then there's a crossing on the far side. So providing adequate crossing for people to access these is also necessary. So you're discouraging mid-block crossings. Some other considerations are some of the off-street facilities that could be key generators for pedestrian traffic. And it's important at these locations to provide direct routes to the crossing enhancements that are separated from other modes. Otherwise, then there's potential that this too would encourage mid-block crossings. Bus stacking as well, when you have multiple buses and a single stop, could create additional desire lines. And again, the degree of concern we're talking about depends upon the context. Closely spaced crossings, having those crossings, and putting these types of facilities on lower volume, lower speed roads are some of the measures or some of the tactics you can employ to reduce some of the conflicts. Passenger demand is always one of those critical things because sometimes you don't know until you put in a stop what kind of demand you're going to get. But again, for operations and safety as well, it's important to designate the stop area so that it reduces that dwell time and reduces kind of random events where the bus stop might stop in one location or another. Of course, too, that's critical as well when you have people who have some mobility restrictions or vision restrictions. So making sure that there's defined stopping zones and that drivers are trained to stop in a consistent location is really critical. Now, some locations too have some unforeseen effects in terms of demand, where you have a location that might have such high demand, the pedestrians themselves are actually if you will, for lack of a better word, a sight distance obstruction for right-turning vehicles. So you can see that cab, that blue cab, if it were turning right, it wouldn't see necessarily pedestrians crossing in that crosswalk due to the volume of people at the stop. So again, it's important to consider demand, and there are things that you can do, expand the pedestrian waiting area outside of those critical sight lines. So, that's a really quick high-level overview of some of the bus considerations. I'm not going to, that just summarizes what we went over. Again, highlighting some of the key things, and I'm going to go right into BRT. So BRT, you can see right here. These are the topics that I'll discuss. Here's some of the resources. Like Dan said, this presentation will be provided so you can look up some of these things on your own, but you're talking about a lot of the same resources. In addition to some of the things I talked about, American Public Transit Association has some good resources as well. So BRT stops, they can look like your regular local bus stops. And when they do, and they're placed along the curb, they have to follow the same principles, where you have to not just account for the stop activity, but the activity associated with the bus. The differences with BRT is that often fare collection space is needed. Again, that's to expedite the boarding process. Pedestrian facilities may be separated so that the people who are collecting their fares, or when their fares are collected, they're in a separated space. And then the boarding may be elevated as well to be like a platform to expedite the boarding and the lighting. So all these elements together are sometimes referred to as a platform. So BRT platforms typically have more transit amenities than a traditional bus stop. The amenities include things such as unique shelters I mentioned, designed to accommodate higher pedestrian volumes, and also designed to accommodate system information in the form of electronic boards or large system maps. These, of course, off-fare board collection, you can see those are highlighted on the slide right there. And all these things combined together really require more space than a traditional bus stop. And you can see the platform length and platform width suggestions are listed on this slide. And you can see here, this is in red highlighted the expanded BRT platform length, and when you have a articulated bus, it would be even longer. So in terms of ADA, for the platform, here's your basic requirements. Of course, it's a flat platform, basically no slope greater than 1 to 48 in all directions. The edges must be protected by either a screen or guards or have detectable warnings. So you can see that yellow strip at the end of that platform, that's your detectable warning. If it is raised in the back too with regard to the sidewalk, then you need to have a platform screen as shown. And then you can also have a screen on the boarding side as well to protect that higher platform height than you have from a traditional curb, where buses have to pull up to the precise location on the platform. So ADA standards for ramps, we've talked about these in some of the previous courses too. Again, some of the keys are that you can't have a running slope greater than 1 to 12, and you have to have level landings at each side of a ramp. Also, you have to have level landings for any time there's a change in direction on a ramp. So here's some of the elements put together on this slide. You can see that there's the ramp platform. There's a ramp to the platform, excuse me. There's protective railing so that there's only a gap in the railing where people would board in the light on this specific one. Again, that railing is there to prevent people from dropping off that higher curb. So these are the elements that you consider when designing your BRT platform. Here you can see something similar where you have fencing and bollards to restrict movement, so you discourage undesired pedestrian movements like people crossing mid-block to the platform. You have low-level plantings which also help provide that. And this is at a signalized intersection, so you have a push button on this island. This is a median island BRT platform here, so you have to have that pedestrian push button to provide that access. Now, some of the unique design features of BRT are having a running way. And you can see here there's two different types of running ways that are showed on this slide. You have a 2-lane median guideway and then 1-lane reversible. But one of the key things to think about this 1-lane reversible is the confusion for pedestrians potentially. You can see there's a cross-section of one as well as that plan view below. And the difficulty is, that they're looking when there's a BRT bus approaching. Now, ideally, you have a signalized intersection here, but sometimes you want some additional warnings so that pedestrians are looking both ways before crossing, or sometimes electronic signage can be provided that alerts pedestrians to the direction of travel. Some areas of caution for platform access. Pedestrians have to cross from either side of the street when you're accessing a median platform. So the areas that are highlighted there in the red circles should provide that pedestrian refuge for pedestrians to wait or cross to push a button if signalized, and then access. They have access to that push button and then they can cross the street. That's similar to one of the slides I showed you. So having that refuge area is critical for really adequate and safe access for this type of configuration. In some locations, you could have unsignalized BRT platform access. In this case, the instance right here, there's very little room so that you don't have any room for refuge between the BRT lanes and the general traffic lanes, which means pedestrian has to cross all at once, and it could be difficult with the difference in speeds between the general traffic and the BRT lanes. So it's better to have some built-in refuge between the BRT and the general traffic lanes when you can do that. And then best is if you could have a configuration where you have like a Z crossing, so you're again directing pedestrians to understand that it's not just one simple crossing, that they're crossing different types of facilities, your general traffic and your BRT lanes, where speeds and characteristics could be very, very different. This is a BRT platforms that shows that in effect, basically. You have a Z crossing right there, so you can see if you're crossing from one side to the other, that you're forced to make that kind of Z maneuver, and you're looking at the traffic and the BRT. You're forced to face traffic, either the BRT or the general traffic lanes. So that provides that ability to let the vehicles and the pedestrians to maintain or to get eye contact, so everybody understands each other's intent. Some of the primary issues that you see with platform access are as well, as since they are longer platforms, is people crossing away from marked crosswalks. Signage is sometimes employed, as you can see here, with limited success, really. So things that you could do to address these concerns could include some sort of railing or other design element, either on the platform potentially or along the street, just to discourage those mid-block crossings. So I focused the BRT really talking about some of the unusual characteristics with the median platforms. Again, there's if we look at how this is delivered in the in-person course, there's more detail. But given the limited time we have today, I'm just highlighting some of those key features. So we'll get right into light rail. See, these are the general topics that I'll discuss. Again, we're following a similar format. And I won't talk about all of these resources, but you can see they're there. Again, Federal Rail Administration has some additional resources that pertain to light rail. Platform design is similar to what I discussed previously. That's a repeat of what I talked about for BRT, but you do have the additional requirements with track crossings, the flangeway gaps that are necessary for the train wheel flanges. And the requirements there is that the wheel flange openings of 2.5 inches maximum are permitted on non-freight rail tracks. So, we're talking about the light rail. Again, ADA standards that's a repeat of what we talked about for BRT. And you can see, the location and operation are kind of really all put together on this slide, where you see you have your ramp to the platform on your photo on the left. You have the platform next to light rail. You have the protective railing to separate that higher platform from your regular sidewalk. On the right side, you see that's just a different view, where you see the ramp and you have your detectable warnings and the platform width as well. This is a pretty narrow platform, as you can see, but it does allow an accessible path, which you're supposed to always maintain. You can see here what's shown is you have to maintain a pedestrian zone too when you have your platform. And you can see, like I had mentioned with BRT, is that typically with light rail, your platform is restricted for only people that are using the station. And there's different ways that agencies will enforce that. So BRT platforms, again, shouldn't block that general pedestrian activity, and they should be well-defined waiting areas outside of those paths. And you can see here you have your main elements. You have your detectable warning. You have your platform, which it's kind of hard to see in this slide, but it actually is a different brick in color and texture, so you can see where the platform is versus the pedestrian zone. Not all locations have that, that textured pavement difference, but if they don't, you'll have like warnings, like you can see circled here is, what area to keep clear for that pedestrian zone. There are other considerations that you think about when we're talking about accessing light rail, of course. Sometimes, placement of bicycles, you think of different locations, and sometimes they have designated areas. And again, a lot of these things are with the purpose of separating conflicts and ensuring that there's, the boarding is in an expedited manner. Crossings should be clearly marked too. And when you're talking about light rail, you typically have signalized crossings. Sometimes in conjunction with the signalized crossings, you can see on the left, that is a signalized crossings, you have to have some additional signage. And that's the signage here. You can see that's look both ways. This isn't an MUTCD, but it keeps the spirit of the MUTCD. And it's designed because you kind of end up with complex situations sometimes at intersections where you need that reinforced indication as to pedestrians what to be cautionary, what to look at. It's a really low volume crossing where there's not a lot of conflicts. It's a turnaround stop for a light rail, and so you have not as there's not as robust treatments there, since the conflicts are less frequent. Your main device sometimes for controlling pedestrian or bicycle crossings when they're by themselves and not like in an intersection are flashers, and those flashers can have gates that are used to warn pedestrians and bicyclists of approaching trains. If you don't have the gates and just flashers, as you can see in this photo, bicyclists, pedestrians will sometimes cross and put themselves at risk. And just so for everybody's clarification, this isn't the light rail is not coming towards the bicyclist, but it's going away from the bicyclist in this photo. So the bicyclist crossed as soon as they got that gap. But again, especially when you have light rail coming from two directions, that could lead to a very serious situation. So you might want to consider, instead of just flashers, putting your gates as well. Sometimes crossing the tracks in a platform isn't an issue when you have a low-speed environment and infrequent conflicts. But when you do have your higher-speed conflicts or higher-speed rail that's servicing a particular area, then you want to have more robust guidance to encourage people where to cross. TCRP Report 17 recommends curbside barriers such as landscaping or fences or bollards with chains to be placed along BRT sideline operations where vehicles operate on the street. You can see here's a location where there is that center platform for light rail, and there was, due to the length of the light rail platform, the arrows in red show where pedestrians were crossing, but something that you want to discourage, where you could have a barrier in place to discourage that. And then that would be accompanied with signal enhancements to provide adequate waiting area and minimize delay for pedestrians at the right side of the screen or the left on either side of those platforms to enable pedestrians to cross in a more efficient manner. There are things that sometimes work, simple measures that sometimes work and sometimes don't. Placing notifications like "Do not cross tracks." Those aren't necessarily completely effective, but sometimes you can see, as the photo on the right shows, you can put in things. This is actually on the platform. The railing didn't extend all the way to the edge of the platform, so people were alighting the platform at that location. So doing some low-cost enhancements in locations like that sometimes is more effective. So the low-cost treatments do have mixed effectiveness, but certainly should be tried before you try some of the more robust enhancements. So, crossing the tracks at mid-block locations, that's one of those key things with light rail. So, moving on, we will get into commuter rail, and I know time is running short, so this is basically what I'll cover. Again, we have the resources that are listed here, and some of the key considerations that I'll discuss are the characteristics are the convergence of modes at your commuter rail stations, where you have vehicles, bicycles, pedestrians, buses, and they all mix where they require well-defined crossings. And this includes parking too, because most of your commuter rail stations, because they are getting a broader area of people to attracting a broader area of people to commute via the commuter rail, requires parking areas too. And those parking areas need to consider the interaction of all of these modes as well. Ensuring that clear paths exist between the parking areas and the entrances is one of those critical considerations. Some of the design features associated with commuter rail or heavy rail is graded separation. That's sometimes the best option for getting people access to the commuter rail. But obviously that can't be provided in all locations, so we'll focus on some of those non-grade separation considerations. you can see at this light rail station, you know, when you're looking at the design, there's just some basic questions you want to make sure that you have thought about, and that's listed here on this slide. You know, like, how are people accessing the station? Is it by bus? Is it by vehicle, bicycle? And are those different areas separated, or are they integrated? And if they are, then you know, are the conflicts separated? You can see on the lower photo shows just some of the, you know, potential conflicts, where you have locations where there are, you know, shoulders provided, which are used as bicycle lanes, but you have locations where the shoulders aren't continuous. So then are they putting people in conflict with each other? Is signage effective, or is it not effective in alerting people to the conditions that are present? So those are considerations of us as well. Again, making sure that there's continuity between all the modes and that there's clear indication where those interaction locations are some of those key elements that you just want to consider when you're looking at that commuter rail station access. At-grade crossings, of course, you know, there's some specific considerations where you want to look at land use, because that can be something that affects the safety of a crossing quite significantly. The land use around the station may warrant additional safety improvements, such as locations where there's a lot of pedestrian generators, such as parks or schools or retail centers. And just keep in mind too is that, you know, where you have a crossing, it might not be used just by people using the transit, but it might be used by people that are local to the community. So that's another need where there's that understanding that there's a need for enhancements. Likewise, predominant pedestrian paths should inform the types of treatments that might be needed. Paths with higher pedestrian activity may require greater focus and you know, greater enhancements and greater communication in terms of use and connectivity of the area. So here's your basic at-grade crossing. The detectable warnings are required, and those should be placed on each side of the rail crossing. As shown in the slide here, the edge of the detectable warning surface shouldn't be closer than 6 feet and no more than 15 feet from the center line of the nearest rail. Where you do have pedestrian gates, and those aren't a requirement, but where you do have those, the detectable warnings should be placed on the side of the gates opposite the rail. So that's your kind of basic configuration for at-grade rail crossing. But, you know, based off of the considerations that I briefly mentioned, there's some other areas of caution that you probably should consider. And I will say that a lot of these apply to light rail as well as your commuter rail too. One of the things is that you certainly want to avoid is people darting across the tracks. Again, that's where you would put in a swing gate in conjunction with the flashing bells and lights that you see. And those are designed to alert pedestrians or to prevent pedestrians from crossing the tracks. It forces them to pause, deterring them from freely running across the track. Sometimes what you have in areas that have more use or more conflict, you would probably put in a swing gate, which is shown on the lower right of this slide right here. And this is all from TCRP Report 17. The swing gate requires pedestrians to pull the gate to enter the crossing and to push the gate to exit on the other side. So a pedestrian can't physically cross the track area without pulling the gate open. TCRP Report 17 recommends that the gates be designed to return to the closed position after the pedestrian has passed by themselves, so nobody can just leave the gate open. again, these are areas that could be used at pedestrian-only crossings on sidewalks and near stations, where there's a medium to high opportunity for conflicts between pedestrians and the rail. Another treatment is this active signs, where they illuminate and provide information of the approaching of a second train. So, sometimes a pedestrian might see a train in one direction and not be prepared for the train in the other direction. Active signs are just alert pedestrians to the direction from which one or multiple vehicles are approaching the crossing. And these are, of course, important where almost in any location, but especially where pedestrian traffic is heavy, such as near a station area. Other things that you want to consider when getting pedestrians across the tracks, or even navigating the roadway network as a whole, are when pedestrians fail to look both ways. Putting in a Z crossing that uses that concept that orients pedestrians to the approaching vehicles. Its design, again, it may be used where crossings are likely to run unimpeded across the tracks, such as isolated mid-block pedestrian-only crossings, and is typically used in locations where the risk of a collision is low. Finally, lighting is another consideration, and that's something that's obviously a critical consideration whenever you're talking about pedestrian safety. But some of the things that sometimes might go overlooked are the heavy demand of pedestrians that are commuting, and commuting in hours of darkness. In the winter months particularly, it's a lot of people will commute and both ways on their trip in the dark, and so that making sure that lighting is provided on areas that are accessing the station is critical as well. So the crossings were the major consideration that I went over with regard to commuter rail. Again, there's a lot of crossover between these different modes in terms of some common elements and some common consideration, or between these different types of transit. So finally, I'll go over streetcars. Again, basically talking about what are some of the key considerations and some of the areas of caution. Okay, similarities. There are quite a few similarities, like I mentioned, with local bus, BRT, and light rail for streetcars. Streetcars use this elevated platform concept so that service is enhanced, so that there's there's less dwell time at the stop, enabling that service to be more consistent. You can see the key elements. Again, when you do have that elevated platform, you have that protective railing. If it's elevated from the sidewalk, you have your ramp, which has to meet ADA requirements. And your platform, too, has to meet your ADA requirements with the accessible pathway along the length of the ramp, and then having the truncated domes to differentiate the boarding area as well. Here's some other features of your platform access. You can see on this slide, this shows where there's a platform, a median platform, and you see you have your median refuge area that provides access to the platform. And like what we've talked about in the previous pedestrian design courses, there's requirements for having that median platform be a minimum of 6 feet, and with a minimum of 2 feet between your truncated domes to provide some waiting area. But when we're talking about streetcar, that platform width is much wider typically, similar to BRT, where it's a platform of 10 feet, maybe even 20 feet, depending upon how it's serving people in the area. Also requirements with the flangeway and the gap, maximum of 2.5 inches gap. So these are all things that we've talked about with regard to light rail and BRT. So it kind of combines some of those common elements as well. You can see here, this is a curbside stop with your streetcar, where you have that tactile warning strip, the length of that elevated platform, your ADA clear zone that is adjacent to that, and sometimes you obviously have a shelter that needs to maintain that ADA clear zone, so the structure itself can't block that zone. And when the elevated platform is separated from the sidewalk, in addition to some of those features that I previously illustrated, you have to have that fence that separates it from the sidewalk when it's elevated, which also requires that ramp up to the platform as well. And again, shelters can't infringe on that ADA clear zone. So this is a medium platform typical design that you see right here. This, again, has some of the same elements. This is typically wider in design, similar to like we talked to BRT. Sometimes these are 10 to 20 feet wide, and then as long as the streetcar vehicles themselves as well. But again, the same elements are here. You have your tactile warning strips, your ramp that goes up to the platform, and you can see here off to the left is that you have that area that I previously described on the median, which is that median refuge area. Okay, so your streetcar areas of caution are that the platform shouldn't block your general pedestrian activity like we talked about with some of the other modes as well, and that pedestrian crossings should be clearly marked. The best is to have them marked similar to signals, with the signals linked for the streetcar as well as the general traffic. So that's the general summary of the different modes or the different forms of transit. So the idea of this is just to give you a sample of what are the kind of considerations that we discuss in the in-person course. So the intent is to determine proper placement, proper design, ensuring that pedestrians have adequate access to the different stops. And also knowing the differences between the different forms of transit, and having a background of this knowledge will help you maybe determine what types of transit you're able to accommodate in your system if you're considering different forms of transit. So that's the end of the formal part. Again, there was, I recognize that with a limited amount of time we weren't able to get into details on every single aspect of the different transit design features, but I think at this point we can open it up to any questions.
Right. Okay, great. Thanks, Dan. And I'll probably leave it on your screen if that's all right, because we may want to refer back to some of the slides that you talked about if they come up in the Q&A.
Yeah.
One thing I wanted to ask right off the bat, you talked right at the beginning. I think you kind of defined each of the different types of transit you were going to discuss. But I wonder if you might revisit the definition of bus rapid transit and sort of drawing parallel or distinctions, I guess, between that and what somebody would consider sort of their typical standard sort of local bus service, and sort of how BRT, I mean, clearly from what you discussed, it's different in many ways. But if you could kind of outline some of those differences, key differences, and maybe why that impacts pedestrians in different ways.
Yeah, no, that's a good question, Dan. You know, basically, you know, the differences of BRT are obviously designed to provide more rapid service to, you know, get more people interested in riding transit. And, you know, because BRT is this more this faster service, is that it usually will operate on at least part of it, like I said, is exclusive right-of-way, or it's exclusive guideway. And with that, you know, comes some differences that might not be anticipated for pedestrians when they're crossing the street. So pedestrians, you know, again, this BRT, you know, ideally won't be you won't be caught in congestion, so you'll have this faster service going on with a more slower congested service. So alerting pedestrians to those differences and making them aware that, you know, if they are crossing in a congested area, that there might be this faster moving service is critical. Now, when you have signals, hopefully pedestrians are, you know, obeying those signals, and you know, that's not an issue. But, you know, again, it's, you know, there's not always adequate right-of-way to provide the best design, so you want to make sure you're providing some of the basic things pedestrians need to access a platform, like in the median, and that would be you know, push buttons so that they could call in that signal phase, and also that adequate area so that people that are not only accessing the platform have adequate indication an ability to cross with the signal, but so that people that are, you know, just crossing the street can get across and not interfere with that traffic, and which would, you know, maybe discourage or encourage people to do things that you know, aren't really intended with the design. So, you know, the critical difference is that the transit way, or, you know, the BRT way, is different, and alerting pedestrians to some of those challenges with that is one of those critical features to make sure that pedestrians are, you know, fully aware of, you know, the potential hazards with that, you know, meaning that speed differential, and looking for which way the BRT is coming, because it doesn't always necessarily follow the flow of traffic. It could be a contraflow BRT lane. And that's something, obviously, that is critical to inform pedestrians about.
Switching gears a bit, you showed a few different options getting to sort of local bus service, different options for stop placement at intersections, whether near side, far side, and a variety of positions. Can you talk a little bit about near side stops? You kind of showed a situation in which you kind of had a bus. It was almost like a bus pull out. You had a name for it. I don't recall it. Bus pull out at the intersection, sort of for queuing, and it sort of looked like almost like a right turn lane that the bus had pulled into. Is that the same design that you'd use for if an intersection had a right turn lane only to keep the bus on the near side, or is that sort of a frowned upon strategy? I guess people are asking if the cars just going to keep turning right in front of the bus and not let it kind of get back through the intersection if it pulls out that way.
Yeah, that's a good question and an important consideration. So, you know, where that, what I called that was, you know, your queue jumper.
Yeah.
Again, what that allows is it allows the bus to pull into that, you know, that lane and get ahead of the queue. So, you know, at the intersection. So those are used in locations, you know, sometimes with transit signal priority, where the transit will get the call before the traffic on that approach. Okay, so they get, you know, faster service. And yeah, the right turns are a pretty big consideration there. Is that, you know, you wouldn't typically use that where you have a high right turn volume. That is one of those, you know, obvious conflict points. So it wouldn't be an area that you would have expecting a lot of right turns. And that's the, I guess, constraint with that. And so there's other ways to, you know, ensure that, you know, buses do get that priority. But, you know, when you're talking about, local bus service sometimes will have this type of queue jumper or BRT as well, but it doesn't always work for the right turns, and so you need to find another location where maybe it does work, or another way to get the bus quickly through the intersection. It's kind of a technique that's used in conjunction with the local travel lanes, but that right turn volume is something that you would want to be very, very low if you're using that. So if it's not low, then you find a different location.
Okay. All right, very good. There's a question here about whether you're aware of any kind of approaches, or maybe more innovative approaches that agencies are starting to look at to help kind of with warning systems for pedestrians to be aware of oncoming vehicles, or maybe warning systems that are available to operators to look out for pedestrians that may be maybe not aware of where the transit vehicles are coming from, specifically with respect to BRT. People are wondering about sort of like connected vehicle or smart detection technologies that might have applications for transit operators to kind of avoid crashes that may be occurring in sort of transit right-of-way.
Yeah, that's something that certainly has been explored much more. Obviously because there's a big interest in that and a pretty big need. I'm not sure of any area that has something employed now other than things that have been experimented with. Some of the things that I did show are like from TCRP report 17. And that's a little bit older now. Some of those things that have been tried, such as the dynamic warning signs that tell from which direction a rail vehicle could be approaching, and I guess theoretically that's something too that is could be used on BRT, because there's a similar type need there, and there are warnings with BRT that shows the direction of travel as well. That's a kind of dynamic message sign. So those are some things that have been employed, but I think that there are things that are being looked at as well. I will say too is one of the things that type of technology is being looked at for as well is with light rail. Fortunately, the light rail pedestrian collisions aren't as frequent as vehicle collisions, like your BRT, your light rail vehicle and automobile collisions. And I think it's probably pretty much similar for streetcars. And so there's technologies that are looking at some of those, reducing those conflicts, which I presume are things that could be applied for conflicts with pedestrians as well, which are a little bit more could be a little bit harder to predict at times if there's a significant level of mid-block crossings. So yeah, again, some of the resources that I provided talks about some particular locations where those things are being tested. But I think that's a great topic area that is certainly an area of great need that I hope gets some interest behind that.
Great. For a lot of the webinars that we've done in this series, they've been on very specific countermeasures, and oftentimes we're lucky enough to have a crash modification factor that's been established, maybe through research, to show that particular countermeasure has had this impact on reducing pedestrian crashes. I don't expect that that's the case for anything that's specific to transit and pedestrian safety. I guess my question is there any CMF or study that's kind of looked at applying pedestrian countermeasures in transit-specific locations, or is it more just looking at the countermeasures that are effective in there are transit stops with the understanding that they would have similar impact?
That's a good question as well. It's really yes, I think that there's acknowledgement that there's nothing that's specific to transit. Now, one of the key factors, of course, in transit is providing that safe and safe access that's approximate to the different stations, to make sure that there's a crosswalk within fairly close to where your station is. So then it gets into the countermeasures for crossings and things of that nature. I think that intersection of where you have your transit design and where people are crossing the street, that's where you have your countermeasures. Those are the types of things you want to employ to help people cross the street in a transit way effectively.
A lot of the some of the questions that have come in were from folks who are in more maybe more suburban or more rural locations where they're saying their transit stops, their bus stops, oftentimes don't even have sidewalks at the transit stop. It's mainly just a sign on the shoulder or on the side of the road. You shared a lot of examples of different features that should be included at transit stops or bus stops, things like level landing pads and benches and other things, lighting. When you're looking at a rural location where there may not even be sidewalks present, what would you prioritize as sort of something or a handful of things that you would say this needs to be, you need to prioritize these at all your transit stops, even if you don't have some of those maybe next level features? Or would it truly be the sidewalk, getting the sidewalk to the transit stop be the #1 priority?
Well, that's a good question. It really depends on ridership. I mean, if you have a remote stop that has almost no transit activity, then it's not maybe having a sidewalk isn't the right approach. But having that accessible route, like an accessible shoulder or something like that, like in a lot of suburban areas, some of the things you see that are used is that you do have your accessible shoulder with adequate width, and then you'll have a landing pad by itself that allows somebody to wait. The landing pad is one of those things that is, if you have somebody with mobility restrictions, it allows the bus to put out the ramp so that somebody could gain access to the bus. So it's not required not a requirement to have sidewalks everywhere, but to have an accessible route, level landing, it's kind of that bare minimum that you would probably want to achieve. And again, if there's areas where that are truly remote, I'm sure there's rules and design exceptions that could come into play where it doesn't have to be an accessible route all along the entire roadway, but from where the origin and destination is. So there's different degrees of that. But again, just having some sort of accessible shoulder and some sort of landing so that somebody with mobility restrictions can access that is kind of your basic level of accommodation that you want to achieve.
Great, thank you. Got a good comment here from someone who's a transit operator or a coordinator for a transit system, saying that it's important to treat transit riders as pedestrians in the planning process. So they coordinate bus stop locations with new mid-block crossing treatments. So that comment, I think, is sort of the gold star of what you'd want to see in a city. And I don't know if it's the case that a lot of cities have the same amount of coordination between their sort of planning departments and public works along with the transit agencies. What would you tell a city that maybe wanted to develop a better relationship with its transit agency to kind of participate in that planning process? Maybe some of the reasons why working with them early on, may have benefits down the road.
Yeah, I think you probably answered the question really well, Dan, is that, yeah, the earlier on process that you can engage a team of stakeholders in the process of siting, and even, a transit agency might come up with a set of design standards for locating or, amenities or features in a transit stop. The earlier on in development of those rules that you can engage transit, the DOT, that includes transit operators too, and other stakeholders, the better. I will say that FHWA's guide, the Pedestrian Safety Guide for Transit Agencies, is something that explores a lot of those relationships really well, because again, it's that coordination that leads to a more thorough understanding, that leads to a better system-wide accommodation of all the users. And again, there's areas that have unique characteristics, and so yeah, I acknowledge that where this is probably more urban focused on a lot of the transit access. In a location that's more suburban or more rural can come up with their own set of requirements or own set of initiatives that conforms to the type of area they're in. But yeah, it's that process which is critical, and sometimes again that involves not only a roadway agency and the transit agency, but that's like all types of people with experience within the transit agency or roadway agency, maintenance people, transit operators, so that people understand what are the needs of the operators too, and how they are trying to safely accommodate pedestrians and things they have to do. So those should be incorporated into the design as well. Like I know sometimes you'll see like where you have kind of roadway widths that provide some opportunity for vehicles to pass. You'll see transit operators, park their bus in such a way to prevent people from passing that could, endanger pedestrians. So, it's important to get that thorough perspective. And again, I will refer people to looking at that document because it does describe a lot of these things in a lot more detail. It has a lot of good case studies that show, when people did kind of come up with a more comprehensive plan, how they were able to address some of the kind of bigger system-wide issues.
A question here about asking to please discuss access to transit and temporary accommodations that can be used during construction. It's not an issue that I guess you got into too much during the presentation. Any special considerations during construction to ensure that you can maintain access to your transit stops and locations?
Well, that's a good question. I think that's something similar that we're concerned about always when you're just trying to provide pedestrian accommodation as a whole and maintaining that. And I'd kind of refer back to the MUTCD on some of those requirements. Again, when you do see like a stop that's relocated temporarily, making sure that the riders have advanced information as to where it's being relocated. The drivers know what the new stop is, what the intention is, where they're supposed to stop and pick up or alight pedestrians, and then having those basic requirements so that people can access it. Putting in ramps so that people can reach the new area. Sometimes you'll see agencies will put in temporary asphalt ramps and things of that nature. So that's kind of broadly, you want to make sure that there's enough advance notice for some of those things. But I guess in terms of the design, it's kind of a case-by-case basis in terms of what's being restricted in terms of pedestrian movement.
We had a webinar a couple of weeks ago as part of this series on roundabouts, and we got some questions today about we looked at different placement options for buses at intersections. They're wondering about for roundabouts. Clearly, there's some different issues there. You're not going to have a bus stopping in a roundabout or right at the entrance or exit. Do you have recommendations, or can you point to anybody to resources on placing transit stops near roundabout locations?
That's a really good question, and I think a lot of that depends on what are kind of the design elements, and they're very similar considerations you would have with a roundabout that you would with a normal roadway. Like if you have a far side stop, you wouldn't place a far side stop on a roundabout where you would be blocking traffic, for instance. That's kind of one of those design considerations when you're placing a far stop in a traditional intersection, but it's also when you're in a roundabout too. So I would suggest that those would be similar type treatments, so that people could still go through the roundabout. You'd have a 2-lane exit from the roundabout if you had a stop that was on that far side. No, that's again, I mean, that's kind of what I could probably say in the amount of time that we have left in the webinar, is that the similar rules apply, and in terms of a good case, nothing really comes off the top of my head in terms of what is really good, but that's something that maybe we kind of look at a little bit more detail and provide some information, because I know I've seen them and I just can't tell you what are like some of the most exemplary cases.
Yeah, and I think a lot of it might come down to, obviously you're not going to have the stops right at the roundabout itself, but it's a question of, how far downstream off the entrances and exits, is the stop, should the stop be so that there's still that easy access, so people will use the roundabout to move to the intersection as opposed to, to crossing upstream or crossing mid-block in a more scattered pattern. And I think on that webinar we saw a few aerial examples of that, but we didn't really get into the design issues associated. So we'll keep taking a look at that for sure. Here's an interesting question, Dan. We may be able to close with this one. You talked a lot about different examples of different transit types and then possible solutions for those. We didn't get so much into a discussion of kind of comparing the different types of solutions for different options from sort of the perspective of whether you're looking at an urban core, sort of downtown, dense urban center versus sort of a suburban kind of greater than 35 miles an hour arterial setting, although you showed examples from both. Do you have thoughts about, for the sort of light rail, bus rapid transit, sort of median stations and stops, how much thought needs to be put into those, the safety of those crossings in sort of that more dense urban environment where maybe traffic speeds are lower, versus looking at that in a more high-speed arterial circumstance where maybe you do want to sink a little bit more thought into improving those crossings with push buttons and Z-pattern crossings and things like that. Is that a consideration, kind of getting at that volume speed question of how you decide how to design these things?
Yeah, I think the question is what are the specific considerations if you have one of those types, not like if you're maybe considering one form of transit over the other.
Right.
So, yeah, I mean, you're looking at streetcar, streetcar is obviously something that's confined to more of your urban areas because it's slower speed and, has characteristics of your local bus. Where, things get, I think, more complicated is where you have your BRT or light rail because they could have characteristics of, and they go through urban areas and they go through suburban areas. They're typically bringing people from suburban areas to urban areas. So yes, the characteristics have to, of the crossings, of the platform designs and everything have to really relate to the environment that they're in. So, you could have a BRT, and this is one of the things that I mentioned, is that, you have this ideal example of what BRT is, which is separated and everything, and, you might be able to achieve that in areas that are more suburban, where you have some right-of-way, but you might not be able to achieve that in urban areas. So, there are some very different considerations that need to be employed for a specific system then, or a specific line, because they might traverse multiple areas. And so, speeds where you're in your more suburban areas, that's one of your primary concerns is having adequate facilities for the speed of traffic, not only BRT, but the traffic in the area itself. Whereas it might be, and of course, when you are further away from kind of a core center area, the spacing of the stops might be very different as well, which means you might have to look at wider access, a kind of wider catchment area of people who will be attracted to accessing that stop. So whereas it might be smaller within a more urban area because there's other transit options. So that is something too that is discussed in a little bit more detail in the kind of more detailed version of the slides, which I went over about 100 here, and the bigger module is 190. That does kind of discuss those differences a little bit more. But again, it's the short answer I can give in this amount of time is that it has to operate within the context of the roadway environment.
That's great. Thanks, Dan. I appreciate that. Unfortunately, that is all the time that we have for a discussion this afternoon. I'm sorry if we didn't get to your question. Our email account, if you'd like to follow up with us about your question, we can try to get an answer to you. You can send an email to webinars@hsrc.unc.edu. We'd be glad to follow up with you about that. I just want to remind everybody that you will be receiving an email later today with a link to the archive page for this webinar where the slides are already posted. That email is also going to include instructions for downloading your certificate of attendance. We'll also be posting the webinar recording to that page in 1 to 2 weeks. I want to let you all know that a very brief survey is going to appear once the webinar has ended. We would very much appreciate your feedback and your comments on today's presentation. I just want to say thank you again to Dan Neighbors for delivering today's presentation, and thanks to all of you for attending today's PBIC webinar. I hope you all have a great day.